Welcome to our course, Natural Language Processing. And in this part of our course, we're going to talk about tokenization. Particularly, we're going to understand how to build our vocabulary using a tokenizer. Tokenization is actually a kind of document segmentation because we group words in a certain text based on their similarities. For us to be able to properly understand what we're talking here, let me share with you the basic building blocks of natural language processing. So we have the tokenizer, we have the vocabulary, we have the parser, we have the token, term, word, and an n-gram. So of course, n-gram can be a bigram and so on and so forth. I have some lessons in the past lessons on all of these things. Please review them for you to be able to properly understand what I'm talking. Tokenization is the first step, let me write here, first step in a natural language processing pipeline. If you won't be able to do this one better, then the tendency is that there would be some negative impact, actually big negative impact on your pipeline for the rest of your pipeline. So you have to be very much careful during this process. So let's start how to tokenize a certain text using white spaces within a string as the delimiter of words. So for example, we have here a certain text. This is actually, I got this from a certain review of the Harry Potter. So the text is Harry Potter's world fate works not only through powers and objects such as prophecies, the sorting hats, wands, and the goblet of fire, and so on and so forth. So what we are going to do here first is we're going to split this one. So what do we do in this case? Using the function split, then we can split the different tokens. So let's execute this one. So as you can see here, we have the different chunks of information. So we have we have Harry's, world, fate. So as you can see, different words are separated from each other. But now here is the problem in this case, 284. So 284, and you can also see the period here. So the question is this: do both of them belong to one and only token? The answer is not. And it's actually definitely the answer is no, because 284 is a different token, and this period or even a point is a different token too. And with that, we normally would like our tokens to be separated from its neighboring punctuations and other meaningful tokens in a sentence. So what I'm trying to say here is that this to it for has its own meaning, period or a point has its own meaning. And we want to be very definite in our separation because each of them has its own meaning and we want them to be separated from each other. So let's find another here. Okay, I think it's the only one we can see. And also this one. So 49, then you have here the close quotation mark, I mean close parenthesis, and then the period in this case. So they're supposed to be separated. And what we are going to do is we're going to import the function or import this package tree, and we're going to use the find all, and we're going to call the text, and we are now to print the tokens. This would be able to solve our problem in this case. So let's execute this one. Okay, now we have already deleted or dropped the period in this case. And where is it? And also in this case, 93 over 4, because the bar is also a different one. The 49 is also different, and there is no more period. Now this one is good. So now the question is this: what is a good token, or what is a good tokenizer? A good tokenizer, you always have to think of this. A good tokenizer should be able to strip off extra characters to create the word. Let me write here so that you would be able to properly see what I am talking. So a good tokenizer. A good tokenizer should be able to strip off extra characters to create the word. So you always have to remember that. And now, in some cases, we don't just want to separate the sentences, but I mean the words, but we also want to split sentences using multiple separators. So in this case, using a regex pattern, we are going to split sentences when you see this expressions or punctuations. So let's execute this one. So as you could see, we have now different tokens, different sentences. We have in Harry's world going to people, that is one sentence. Repeatedly going to choice, this is one sentence. For example, going to this one is also one sentence. So using this one, function compile, and using these ending expressions or punctuations, we are able to detect the sentences, and we are also able to split the paragraph into different sentences using the split function, and also using find all and using these parameters. We are able to do that. So now we can also do tokenization using NLTK. So anyway, NLTK is a module that has, or NLTK has a module, word tokenize for word tokenization, and send tokenize for sentence tokenization. So we are just actually doing this here using NLTK. So first of all, we're going to import NLTK. Okay, and then we will just download the punct. Okay, and from NLTK, we again import word tokenize. Okay, it's there. It's now we are going to tokenize the text. So which means to say we are going to have this kind of results. So let's execute this. So we have the word tokenize is coming from the NLTK, and we call the text, the one we have just earlier. So let's execute this one. So now you have in here. So same problem actually that we have in this first instance here. So we have this kind of problem, and we also would like to have this kind of solution to this situation. So actually we have here a lot of expressions now. A lot of punctuations apart from this, comma. We also have this, and we also have this. So what we're going to do is we're going to import regex tokenizer from NLTK.tokenize, and then regex tokenizer. So we assign what these things to see, and then we call the text. So let's execute this one. Now it is actually better. So this is one way of doing this. Another way, of course, we can also use the find all, and I think this one's my favorite because it's not actually very long, so you can just see some sort of a paragraph. Okay, like this one. So definitely the result is something like this, of course, because we use the same function. Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free, like Machine Learning Essentials, Deep Learning Mathematics, and a lot more. Here, you can always learn an upskill for free.